This video is about scientific notation, and before we get too far in that, we're just going to look at some powers of 10. And so 10 to the first is just 10, and so the value is 10, and the number of zeros that it has is 1. 10 squared is 10 times 10, so that's writing it in expanded form, and 10 times 10 is 100, and the number of zeros it has is 2. 10 raised to the third is 10 times 10 times 10. And if you do that calculation on your calculator, you get 1,000. And the number of zeros it has is 3. And then 10 raised to the fourth is 10 times 10 times 10 times 10. And so again, you could compute that on your calculator, and you get 10,000. And that has 4 zeros. And then 10 to the fifth is 10 times 10 times 10 times 10 times 10. 10 being multiplied to itself 5 times. And again, you could do that on your calculator if you wanted. Oops. And if you do that on your calculator, you will get 100,000. And so that has 5 zeros. And maybe you picked up on the pattern before we even got to the end, but if you notice here, the exponent and the number of zeros match. And so when you have 10 to the first, you have 1 zero, 10 squared has 2 zeros, and 10 cubed has 3 zeros, and so on down to 10 to the fifth has 5 zeros after the 1. So the exponent equals the number of zeros. So if we follow that logic for that pattern, then what do we suppose 10 raised to the 0 is? Well, you can actually do that on your calculator, and it's 1. And in fact, it doesn't matter what number you raise to the 0 power, anything raised to the 0 power is 1. And so now, definition of scientific notation: a number written as the product of a decimal number between 1 and 10, and a power of 10 is said to be written in scientific notation. And so a number in scientific notation always has this form. So there will be some non-zeroed number, and then a decimal point, and then there may be some other stuff. You could just have, 2 times 10 raised to some power. So this is written in scientific notation. You don't need to have a decimal point and other numbers beyond that, but this is always some non-zero number. So this will never be a 0 in this position. And then, again, you may or may not have stuff after the decimal. And then times 10 raised to some power. So you can use your calculator to find the standard form of a number that is in scientific notation. To compute numbers with your calculator, you would use the key EE, capital E, or EXP. If you don't have one of those keys, then you can type times 10 and then the caret symbol, which most calculators have. So if you want to compute 5 times 10 to the third on your calculator, you can type the following depending on what your calculator has. So 5EE3, or 5E3, or 5EXP3, or 5 times 10 raised to the third. My times 10 to raised to a power is this button right here. And there's also a 10 to the x button here as well on my calculator, where you would be able to enter that in. So I could have also, so I did 5 exp3 and enter. Okay, so now let's do some computations using our calculators and scientific notation. So first of all, we're just going to write these numbers in scientific notation. So again, you always want to have one non-zero digit in front of the decimal place. So this I'm going to have to write as 5.120. We want to write this as being multiplied by some power of 10. And so in a whole number like this, there's really a decimal point. It's right at the end of the number. And so I had to move my decimal 1, 2, 3 positions to the left. So that means that this would be raised to the positive third power. and it's because of how many places I had to move my decimal point. So for our next one, 2,600,000, so that's going to be 2.6, and you don't need to tack on the rest of those zeros after that. And it's going to be times 10, and we had to move, our decimal number starts at the end, and we had to move it 1, 2, 3, 4, 5, 6 positions. And so that's going to be times 10 to the 6th. And so now we have a really big number, and this is the personal income of Americans in 2007. And so we want one non-zero digit before the decimal point, so that's going to be 1.17 times 10, and this is 3, 6, 9, 12, 13. 4.72 times 10 to the 5th. So this 5 means we have to move our decimal 5 positions to the right. Okay, so here's 1, 2, and then we need 3, 4, 5. So I need to tack on an extra 3 zeros. So 4, 7, 2, and 3 more zeros. And so that moved our decimal point 5 positions. In our next one, we have 3.5 times 10 to the 11th. So we only have one place to move our decimal point to get it to the end of the number. So that means I'm going to need to tack on 10 zeros. So 3, 5, and then 10 zeros. And put commas in after every 3. Okay, so now we're going to do some calculations using our calculators with scientific notation. Our first problem is 3.26 times 10 to the 4th times 5.8 times 10 to the 3rd. And so we're going to type that into our calculators just as we see it. So 3.26, and then we have EXP, or however you type that into your particular calculator, raised to the 4th, and then we're going to close the parentheses, and then times, and in parentheses, 5.87, and then on my calculator it's EXP, and then type in the power, which is 3, and then close the parentheses and hit equals. And so there's what we get, 191, 362, and then 3 zeros. And our calculator, my calculator, gave it to me in standard notation, and that's how we wanted to express our results anyways. So that is all we need to do there. So now the next problem is 750 times 10 to the 17th divided by 25 times 10 to the 7th. And so we'll type that into our calculators. Remember to put the numerator in parentheses and the denominator in parentheses. So we'll have a parentheses and then 750, and then hit your power of 10 button, and then type in your power, which is 17, and then we're going to close our parentheses, and then it's divided by, and in parentheses, 25, and then do the power of 10 button, and type in your power, which for mine is 10, and then close off the parentheses and hit equals. And so I have a 3 and 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then every third zero starting from the back, you put a comma. So 300 million. And now our next one, 25 times 10 to the 3rd plus 750 times 10 to the 2nd. So let's bring up our calculator again and type that in. First clear off our old one, so we want a parentheses, and then 25, and I'm going to hit my power of 10 button, and the power is 3. Close off my parentheses, hit plus, and then another set of parentheses, and then we have 750, and then my power of 10 button, and my exponent is 2. And then I'm going to close my parentheses and hit equals, and I have 100,000. Okay, so now we have a couple of word problems. The distance traveled by an object moving at a constant speed is given by the formula d equals rt, where d represents the distance traveled, r represents the rate or speed of the object, and t represents the time the object is in motion. Light travels at a rate of approximately 1.86 times 10 to the 5th miles per second. It takes 500 seconds to travel from the sun to the earth. Use the formula d equals rt to determine the distance between earth and the sun. So d equals rt, and so we're given the rate. The rate is 1.86 times 10 to the 5th, and we're also told how long. 500 seconds is how long it takes. So that's the variable t. So you're going to have 1.86 times 10 to the 5th times 500. So let's put that into our calculator. And so we want a parentheses and then 1.86 and then my power of 10 button, and the power is 5. And then close that parenthesis and then hit times, and then another parenthesis and 500. And then close off our parenthesis and hit the equals button. And we have 93, and we have 1, 2, 3, 4, 5, 6 zeros. And the unit, this is miles, because this is distance. And one last problem here. This star, I don't know how to pronounce that, but that star is contained within the Big Dipper constellation, and it's about 4.65 times 10 to the 14th miles from Earth. Use the formula t equals d divided by r to determine how long it takes light from this star to reach Earth. Light travels at a rate of approximately 5.86 times 10 to the 12th miles per hour. So we want to calculate t, which is d divided by r, and we have the distance. This is our distance. And we also have the rate. And so we want to take the distance, which is 4.65 times 10 to the 14th, and divide that by our rate, 5.86 times 10 to the 12th. Okay, so let's calculate what this is. So we want a parenthesis, and then 4.65, and then our power of 10 button, and the power is 14, and then I'm going to close my parentheses, and then the division symbol, and the parenthesis, and then we have 5.86, and then the power of 10 button, and the exponent there is 12, and then I'm going to close off my parenthesis and hit equals. And so it's 79.35. We want to know how long it takes, and the units on our distance are miles, and this is miles per year. So the units on this, then, the miles will cancel out and you'll be left with years. So it'll take approximately 39 years for the light to travel to Earth. So that ends our lecture on scientific notation. Let me know if you have any questions.